All right, so energy, that's what we're talking about here. So I'm going to give you two definitions for energy. One is going to be the book definition, so let's do that first. Energy is the capacity to do work or transfer heat. If you do something to an object, you apply a force on it over a distance, you're giving it energy, or if you heat something up, you're giving it energy. Now, my definition, like the book definition, but I thought you should see it. Energy is either movement or the potential to move. So anything that's moving, a person who's walking or running, a car driving down the street, a ball that's rolling, they all have energy because they're moving. Or anything that has the capacity to move on its own without you having to move it. For example, let me take out a psychology book because I don't want to damage a chemistry book. This has the potential to move because it has height. I don't have to push it downward, I just have to get out of its way, and it falls. So because it was up high, it had potential energy up there. Once it falls to the floor, now it has no more potential energy. It doesn't have the potential to move. Although we're on the second story, so technically I could take it out the window and drop it farther. Once it started moving, the energy turned into kinetic energy. It was moving, but it was losing height. So potential energy turned into kinetic. Then it hit the ground, the energy went away, turned into other stuff, sound and heat and so on. So that's potential energy. Height gives you potential energy. There's other forms of potential energy too. Your car has potential energy if it has a full gas tank or a half a gas tank or any gas in the tank. Because that car can move itself because it has gas. If the gas tank's empty, it has no potential energy. So that's chemical potential energy. There's chemical potential energy in your kitchen. You got food that has sugar, has starch is basically sugar, protein, fats, all those things are potential energy. They can give you energy, make you move. Without that potential energy, you would stop working. So any form of either chemical potential energy or energy due to height can produce movement. So we're going to say, what do I want to say here? All right. You know what? I'm just going to leave it like that. I think that explains it well. All right, so let's go into each of those separately, give you a definition. So kinetic energy. This is the energy an object has because it is moving. So this is you're running, cars driving, airplanes flying, whatever. Anything that has movement has energy. And then potential energy is, you know, I'm going to put stored energy. Either due to height or stored chemical energy.
Is on the first row supposed to be stored?
Thank you. So a piece of wood has chemical energy. You can light it on fire and get heat from it. Coal has energy, methane has energy, gasoline has energy. Like I said, all food has energy. And then any object that has height, right? You think about a roller coaster, you drag it to the very top of the hill. There at the top, it has potential energy, it has the potential to move. And then the thing just kind of lets it go and it starts going. And then as it falls to the bottom, it's going really fast. Now it's all that potential energy turned into kinetic energy. Now it's moving fast, but has very little height. Then as it goes back up a hill, kinetic energy goes away, it slows down, but that turns into potential energy because it's high again. So that's a good illustration of how things can go from one to the other, back and forth. Now with this, there's other types too. It's not just either chemical or due to height. If you pull a bow back and you're about to shoot the arrow, that has potential energy. As soon as you let go of that bow, that arrow is going to take off on its own. If you compress a spring, that has potential energy. You let go of that spring, it's going to fire the object, it still has potential energy. So anything that can produce movement without you doing it, without you having to push it and make it move on its own, but you just let it go and it'll move on its own, that has potential energy. Questions on that? All right, last thing I want to tell you today, and I don't know where I want to write this. Everybody's got the top here, right? So, units for energy. Energy is one of those funny things where you have 4 or 5 different units. Energy units. Okay, so most common is the joule, named for James Prescott Joule. This is the metric unit for energy. So it's the most common one we use because it's made up of kilograms, meters, and seconds. And we'll talk about that some other time. Calorie. So when we say how many calories are in your food, which are actually kilocalories, they're talking about how much energy you could potentially get from that food to make you move, or you could store it as fat or glycogen. What else is there? BTU, British thermal unit. You usually see this with air conditioning and heating. Kilowatt hour. This is the stupidest unit there is. It's actually a combination of power times time, which is like, I don't know. One day I'll explain to you why it's a stupid unit, but it really is. And then there's the electron volt, which is a tiny, tiny amount of energy that we use in particle physics. So those are the 5 probably that you might hear of someday. Joules and calories are all you got to worry about. Joule, like I said, is the metric unit for energy. Calorie is the amount of energy it takes to heat 1 gram of water by 1 degree Celsius, so that's why we use that one. Questions on that? Good, we are done. I don't feel like talking a lot today. Yes.
Thanks for credit.
Not for stopping.